Hey everybody, thank you for joining us for Infrastructure is Code with the AWS Cloud Development Kit. My name is Jason Fulgham and I'm the Software Development Manager for the AWS CDK.
Hey everyone, I'm Elad. I'm the Principal Engineer for the CDK. Thanks for coming.
We just recently GA'd the AWS CDK about a month ago, and we're really excited to be here today showing you how you can use the CDK to model your infrastructure and use familiar languages to create these infrastructure patterns that you can share.
Yeah, it has been a pretty exciting month for us. We've been working on this for over a year and a half. It's been in developer preview for a year. A huge shout out to our team and to all the amazing contributors and community who have already been involved in the project. It's been a delightful experience so far, and we're just getting started.
So here's our plan for the session today. We're going to give you a little bit of information about the main concepts in the CDK, and we're going to try to get through that really quickly so we can spend the bulk of our time building an app from scratch using the CDK. And then after that, we'll save a few minutes. We'll show you some resources where you can go to learn more about the CDK.
Okay, before we dive into coding, which is what this is all about, let's do a little introduction and introduce a few concepts so we're all going to be on the same page. Last year at reInvent, Jason and I gave a talk and described a little bit the background for building the CDK. What we've observed was that if in the past a typical service would consist of a fleet of hosts and maybe a database, modern cloud applications would use dozens, if not hundreds of resources, and teams just didn't have the tools to be able to manage this complexity. We realized that many of these problems have already been solved in application code. And so the AWS CDK is a multi-language framework for defining cloud applications using familiar programming languages. By bringing infrastructure definitions to programming languages, we can now use all the incredible tools, best practices, and techniques that we use to develop applications and solve many of the problems at once. When we designed the CDK, the fundamental capability we wanted to provide was the ability to express cloud abstractions of any complexity. We call these abstractions constructs, and you'll be hearing us talk a lot about constructs in this session. To make sure teams can really leverage their existing skills, a CDK is available in multiple programming languages. As Jason said, we have GA support for Python and TypeScript, and we also have Java and .NET in developer preview. So let's see how this works. You write your code in one of the supported programming languages. CDK applications are structured as a tree of constructs. The root of the tree is the app, and then within that app, you basically compose constructs together that formulate your application. It formulates stacks and resources and arbitrary abstractions. Then you use the CDK CLI, which is a command line tool that we ship with the CDK, to synthesize a CloudFormation template from your application. The nice thing here is that you're basically using a imperative programming language in order to define the desired state in a declarative way. So you basically enjoy the power of CloudFormation as a provisioning engine and the power of programming languages for the expressibility and the ability to actually define your architectures. We kind of like this analogy of a compiler. If you think about a compiler takes your source code and compiles it to an assembly language. And so the CDK takes your application and compiles it down to CloudFormation. The CDK is shipped with 3 components. It includes the core framework, which is the construct programming model, the stacks, the apps, the basic primitives. On top of that, we're building a rich class library of constructs for AWS. Those constructs represent all AWS resources and allow you to interact with these resources through rich object-oriented APIs. The third component is the CDK CLI that I mentioned earlier, and we're going to see how it's used throughout this session to take us through the workflow of developing CDK applications.
All right, let's get into the meat of this session and start building an application together. So in our demo today, Alad and I are representing co-workers at a fictitious company called Walters Co. And it looks like the boss has sent me an email and he's made some promises to the marketing team, and now he needs me to build this URL shortener as fast as I can for our website. So this is going to be a fun demo with the CDK. We're going to get to see how the CDK works and explore a little bit of the Construct Library. And this is the application architecture that we're going to be building today. So we're going to create a CDK application. Within that application, we're just going to have a single stack. And within that single stack, we're going to have an Amazon DynamoDB table that stores the mapping data for us from the short URLs to the long full URLs. We're going to have an AWS Lambda function. This Lambda function is going to implement really our back-end code. It's going to create short URLs and retrieve short URLs and work with the data in the DynamoDB table. And then last but not least, we're going to wrap our Lambda function with an Amazon API Gateway endpoint. And that API Gateway endpoint is just going to make it really easy for us to call our Lambda function with a regular HTTP request. So now that we know what we're building, let's jump over to the terminal and let's start building this. So the first thing I need to do is carve out a little bit of space for us to build this project. And then we're going to use our first CDK command, CDK init. CDK init is a great tool for creating CDK projects. You don't have to use CDK init. You can create your project any way you want and add the right CDK configuration. But CDK init gives you a couple of different templates and several different language choices as well. So we're going to use CDK init with Python because we want to play with the new Python support in the CDK. And then now that we've got our project created, I want to go ahead and get PyCharm started. And the first thing I'm going to do is go ahead and plug in all of the dependencies that we need for our demo. So I'm going to get these plugged in, and then I'm going to, first I need to start up our virtual environment so that pip will cache everything into our workspace here. And then I'm going to go ahead and run pip install. This is going to install all of our dependencies, get them set up in our project. So we'll give this a minute to cache everything. We'll give PyCharm a minute to update all its dependencies. And let's take a quick look at the rest of the code in this project. So the starting point for our CDK application is this app.python file. And we can see this is a really simple Python file here. We are creating our CDK application, just like we saw in our architecture diagram. And then we're creating this URL shortener stack. So this maps up directly to what we saw in our architecture diagram. We've got our CDK application, and we've already got this URL shortener stack defined for us. So let's jump into this class here. So the CDK init template went ahead and created this stack subclass for us. And this is where we're going to plug in all of our infrastructure. So let's go back to our map here. And we're going to kind of build this application from right to left. So we're going to start with DynamoDB. We're going to model all of our infrastructure. And then we're going to test this out and see if we can get each piece working along the way. So the first thing I'm going to do is model this table. And to do that, I am going to open the CDK API reference. And I'm just going to take a quick look at the DynamoDB overview. So this is the overview information for the DynamoDB module in the AWS Construct Library. It says a lot of nice information on how to use the different constructs that are provided by the module. And right at the top, we've got some sample code that shows us how to pull in the DynamoDB module and instantiate a new table construct. So this code right now is in TypeScript, and we're working on making these samples available for all the languages that we support. But right now, it's pretty easy for us to map this TypeScript example into Python. And there's even some documentation down here that gives you more tactical advice on how to do that mapping. So let's go back to PyCharm, and let's go ahead and pull in DynamoDB. So we've got this module imported. And let's just create a DynamoDB table from the DynamoDB module. Now, whenever you're instantiating a construct, you're going to have this same pattern where the first parameter we pass in is the enclosing scope. So this is the construct that essentially contains the new construct we're creating. And for the most part, you're always going to pass in self or this. And in our example, that's exactly what we're going to do. And that just means that this URL shortener stack instance that we're creating this table in the context of that URL shortener stack. So you can think of this table as being contained by this URL shortener stack instance. So that's that first parameter. It's typically going to be self for this, and that's how you connect everything up together. This next parameter is an ID. So we're just going to call this our mapping table, and we'll see how that ID gets used a little bit later. So the last parameter we need to supply, we can see over here in the documentation that partition key is a required parameter we have to specify. So let's go ahead and start defining that. If you've ever used DynamoDB before, you know that the partition key we need to specify is an attribute. So DynamoDB.attribute, we're going to create a new attribute to model what we want this partition key to look like. And it's going to be name ID, and type is going to be a string type, and we're going to use this attribute type class to grab that constant there for us. So one line of code, we've got our DynamoDB table modeled now. Let's jump back over to the command line and let's take a look at how we get this deployed. So the CDK deploy command is going to run our program, and it's going to synthesize a CloudFormation template and then send that to CloudFormation. So if we look over here in the DynamoDB console, we see that there's this brand new table, and you can see this mapping table, that ID that we specified is showing up there in the name, and we can see this table is being created. So let's jump back to our slides. We've got our DynamoDB table modeled. The next thing we need to do is create our Lambda function. So back to PyCharm, the first thing I want to do is carve out some space for our Lambda code. So let's create a new directory called Lambda, and let's add a new file in there. We're going to call it handler.python. And then to save some time, we're going to go ahead and plug in all this handler code. So let's walk through this code real quick. We've got just shy of 100 lines of Python, so this is a pretty simple little Python script here. In the main method, what we're doing is figuring out if we need to dispatch this to the handler for creating a new short URL, or if we need to pass it off to the method that retrieves an existing short URL. So if we get dispatched to this method to create a short URL, we're going to look in the environment and grab the table name environment variable, and that's going to tell us what table we're working with. So we know which the name of the DynamoDB table that we want to store and load data from. And we're going to talk about why we do this in just a few minutes, but essentially this is what is allowing us to let our application code be aware of the infrastructure that we've provisioned and know which resources to talk to. We're going to create a new unique ID, and then we're going to use the AWS SDK for Python to store that into our mapping table, the ID and the full long URL, the target URL. And then we're just going to return a 200 response in this case and pass that URL back to the user to use. If this was a request to retrieve a short URL, we're going to do something very similar. Again, we're going to pull the table name out of the environment. Then we're going to use the AWS SDK for Python to read that ID from the DynamoDB table. And then if we find that, we're just going to return a 301 response to the client. And that 301 HTTP response is, of course, just going to force our web browser to redirect to that full long target URL. So pretty simple Python code that we're working with here. Now that we've got the actual code that's going to run in our Lambda function, let's figure out how we can model the Lambda infrastructure that we need to run that code. So just like before, I am going to use the API reference for the CDK. And if I look at the overview page for the Lambda module, I've got a lot of information about how we can configure Lambda infrastructure. And again, right at the top is the sample code I need. We need to pull in the Lambda module. Then we need to instantiate this function construct. And we're going to pass these three variables, or these three properties, into the construct to configure our infrastructure. So let's go see if we can figure out how to do that in PyCharm. First thing we want is to pull in Lambda. And then next we want to create this function construct. So from the Lambda module, we're just going to instantiate function. Same thing as before, we're going to follow the same pattern for every construct we ever instantiate, passing in the enclosing scope, and then passing in an ID. We're going to call this backend because it's essentially implementing all the backend logic to create and retrieve those URLs. And now we start to get to the Lambda function specific properties. So again, looking at the documentation over here, I see that we've got these three required parameters. Everything else is optional. I've got to specify the code, the handler, and the runtime. So let's start with runtime. So runtime is just going to tell Lambda what language runtime to execute this code with. So there is a runtime class in the Lambda module, and that enumerates all of the different runtime options for us. We're going to use Python 3.7 for this example. Next up, I'm going to specify the handler. And the handler just tells Lambda where to start executing code. We put all of our code into a main method in this handler file. So we're just going to call it handler.main, and that's going to tell Lambda to start executing from that main method. And then last but not least, of course, we have to tell Lambda where to get our code from. And to do that, we're going to use another neat feature of the CDK, and that's the asset subsystem in the CDK. So we're talking a lot about how we use the CDK to model our infrastructure, but of course we also have application code that's using that infrastructure, and we want that all to be tied together very seamlessly. So assets are what allow us to tell our infrastructure what runtime code needs to be packaged up and configured for our infrastructure. So again, in the Lambda module, we've got a class called code that makes it very easy for us to package up assets. And we're just going to pass in this Lambda directory that has our code in it. And that's going to tell the CDK that this is an asset that needs to be available at runtime, and it's going to configure our Lambda function to use the code from that asset. So that was it. In that line of code, we now have a new Lambda function modeled. Let's jump back over to the terminal, and let's run CDK Deploy again so we can get this infrastructure created for us. And notice that it's a little bit different this time. We didn't see this prompt the first time we ran CDK Deploy. But in this case, we're making some changes to permissions in our AWS account. And we want to make sure that you understand those changes and that you explicitly acknowledge anything around security changes, because that's so important. So in this case, we've added this new Lambda function, and that Lambda function needs a role to execute with. So that's exactly what we're seeing here. That makes sense to me, so I'm going to go ahead and let that deploy. And let's take a closer look at our code. We've got our table created, we've got our function modeled, but this code isn't going to work together yet. There's two problems that we need to fix. The first one is that our function doesn't have permission to work with the data in our table yet. So we've got to use the CDK to express our intent that we want this function to have permission to work with the data in the table. So if you've ever used IAM policies before, you know that it can be difficult to configure a very high quality IAM statement and lock everything down to resources and actions. With the CDK, the kind of overall theme that we're going to be seeing over and over is that the CDK allows you to abstract and work at a higher level and express your intent, and let the CDK do some of the work underneath to tie that together into all the details. So let's take a look at what we have on table. If we look at this table object, we see we have a lot of different methods available to us. In particular, we have all these grant methods. So these grant methods are what we use throughout the AWS Construct Library. You're going to see this pattern. And this grant method is how we grant permission to resources. So this is just one of the patterns that you'll see throughout the construct library. Permissions is a big one. There's also patterns around configuring event sources and working with metrics. But in this case, we're going to use this grant read write data method, and we are going to pass in our function. And that's all we have to do. So if you can compare this with the experience of writing a IAM policy, this is much easier to read. We don't have to know about all the low-level details. We can just trust the CDK is going to create that nice, tight security policy for us. And in a minute, when we see what it creates, we're going to see that it's very, very scoped down to only this one single table for only the actions that we specified. Those are read and write actions, and only for this Lambda function. So we get the benefit of this high-level intent that we express. It's very easy to read, but at the same time, we have all the security, least privilege, best practices going on. Okay, so that one line of code solves one problem for us. But we still have one more problem. The Lambda function code that we looked at, remember, it relies on the environment variable, that table name, in order to know which DynamoDB table to talk to. So let's take a look at what's available on function. And this very first method that comes up, add environment, tells us adds an environment variable to the Lambda function. That's exactly what we need to do. So we're going to add this table name as an environment variable, and we're just going to pass in table.tablename. So the result of this code is going to be exactly what we expect. Our Lambda function is going to be executing, and the environment is going to have this table name environment variable set to the right table name. But if we look at this a little bit more closely, we see that there's actually something pretty neat going on. So remember that when we execute our CDK application, what we're really doing is creating this desired state, this model of what we want our infrastructure to look like. We're not actually provisioning the infrastructure when we run this code. We're only creating this desired state representation. So at this point in time, when this line of code runs, we're not actually going to know what that table name is. So what's actually happening underneath the covers here is we're using the token system in the CDK. And tokens allow us to do this late binding at provisioning time. So even though we don't know the table name when this code is run, we're going to output in our desired state this kind of forward reference that allows it to be resolved at provisioning time. And we end up with exactly what we expect happening and getting everything wired correctly when it provisions. So let's jump over to the terminal. And let's introduce one more new CDK command. So that is CDK Diff. CDK Diff is probably my favorite command. As you're iterating on your CDK application, it's just incredibly useful to be able to see what's different between what I've changed locally in my workspace with what I've deployed. So in this case, we see that there are two sections in this diff view. This first part is going to highlight any security changes. And we see exactly what we talked about when we added that one line of code to grant our function permission to write to our DynamoDB table. We see that this is locked down to this specific mapping table. No other tables are affected by this. The actions are locked down to all of the read and write data actions available for DynamoDB. And it's granted to our backend Lambda function service role. So that all checks out. That's exactly what we expected to see. Scrolling down to this next section, we can see all of the changes for our resources. So we've got this new policy that we just talked about that grants permission for our DynamoDB data. And then we can see our Lambda function already exists, but it's been modified. This environment variable table name has been added just like we talked about. And there's also this dependency to make sure the policy has been created. So all of that checks out. So let's go ahead and do a CDK deploy. We're going to acknowledge the security changes that we've already reviewed, and we're going to let this roll out and get this infrastructure provisioned. So we're getting pretty close now. We've got our DynamoDB table, we've got our Lambda function code hooked up. The last thing we need to do is wrap our Lambda function in this API gateway endpoint. So same thing as before. I'm going to go back to the API reference. I'm going to look over the API gateway module. And I see that this Lambda REST API, This is really the easiest way to wrap an API gateway endpoint around a Lambda function. So that's exactly what we're going to use in our code. Same thing as before, we're going to pull in API gateway. We're going to create an API. And it's this Lambda REST API that we just talked about creating. We're going to see the same pattern for every construct we create. And then the only required parameter we need to specify here is the handler. So for handler, we're just going to pass in our function. So one line of code was all it took for us to create this new API gateway endpoint and wrap it around our Lambda function. Let's go back to terminal, and it looks like our last deployment has finished. So let's go ahead and deploy this API gateway endpoint, and then we will test it out. So again, we see that there are a lot of permission changes. We've already reviewed these. We know that we're adding Amazon API gateway around our Lambda function. So this all checks out. Let's let our deployment go. And let's talk about one more piece while this is rolling out. So when this deployment finishes, we're going to have an Amazon API gateway endpoint that we can hit, and we can access our URL shortening service. So that's great, but it's going to be this long Amazon API gateway specific URL. And we would really like this to be hosted as on our main company's domain at waltersco.co. So what we'd really like to do is add this as a subdomain, make the API available under our main domain name so we get a nice short URL, and we just have a very professional looking service running. So in order to do that, we're going to talk about how we share some code inside this company. But before we get that, let's just do a quick sanity check and make sure that our API gateway endpoint is working before we hook it up to the main site. So I'm going to plug in our URL here. This is looking great. Just like we expected, we get the 200 response with usage info. And we're going to plug in target URL. Let's see, let's go to one of my favorite sites, the CDK homepage on the AWS site. So we get another 200 response, and we get this URL. And you can see this is what we were talking about before. This is the API gateway default URL that we get. We'd like that to look a little bit nicer in our next revision. But let's plug this in and see if it works. So sure enough, you can see that it very quickly redirected us to the target URL, just like we asked for. So everything's looking good. Our API gateway endpoint looks like it's working correctly. So let's go back and talk about how we actually get this hosted on our company's main domain. So one of the great things about the CDK is that it lets you shape your infrastructure and create these infrastructure patterns and share infrastructure very easily between teams, just like we share libraries of code. So our company does the same process. We have this Walters Co common module that has all of our infrastructure patterns in it. It has access to our domain, to our certs, to all of this kind of common infrastructure that all the application development teams need. And we've got that hosted on an internal Python module repository. So we're going to go ahead and add that to our project. So that's Walters Co common. So we've loaded in that new dependency from our internal repository. Let's take a look at how we use that. So from Walters Co common, we are going to import this Walters Co stack. And that's just one way, one example of how you can share infrastructure patterns. We have overridden or subclassed the core CDK stack with this Walters Co stack. And all the application dev teams use that as a common base for the stacks they build. So in this URL shortener stack, we've swapped it out to extend from Walters Co stack. And let's take a quick look at what we get from Walters Co. So right here, the very first method that comes up, we've got map Walters Co subdomain. And the documentation says this is going to map a subdomain of waltersco.co to an API gateway endpoint. So that sounds like exactly what we want. The subdomain we want to use, we're going to keep it nice and short. We're just going to call it go. And then the API is, of course, the API we just created. We're going to pass that in too. So let's jump back over here. Now that we've got this hooked up into our main website, we're going to go ahead and deploy the changes. And again, we expect to see some permission changes. We know what these are. We've already reviewed them, so we're going to let them roll out. And let's give this a minute while this infrastructure is provisioning and everything is getting set up. Let's jump back to our slides and quickly recap what we did in this first part of the demo. So here's the architecture that we've ended up with. We've got our CDK application. We've got a stack that extends from this shared stack that we use inside our company that gives us access to our domain hosted by Route 53 as well as the cert. And then, of course, we walked through building these resources using the DynamoDB constructs and Lambda and API Gateway endpoint. And while we were building all this, we got to see how we use the CDK CLI. We used init to create our project. We used deploy to get everything provisioned to AWS. And we used diff to see the difference between what we've modeled locally and what we've already deployed out to AWS. There's a few more CDK CLI commands. Synth is one that you might want to use to see the synthesized desired state configuration. That's going to show you the CloudFormation templates that CDK creates for you. So you might want to share those with other teams or use other tools to review those, or you might just want to dig in and see exactly what the CDK is producing. The other big thing we saw in this demo was just taking a tour of the AWS Construct Library. So we saw how we can use the documentation and the API reference to explore the Construct Library. We also started seeing some of these patterns that are used throughout the AWS Construct Library, particularly things like granting permissions that, again, let us work at a higher level and express our intent and let the tooling deal with all the details and making sure they're correct. So let's jump back to terminal, and it looks like our deployment has completed. So we've got the moment of truth now. Let's go to go.waltersco.co and see what we get. So far so good. We've got the usage information. Let's plug in target URL. Let's go to the CDK homepage again. And sure enough, we've got this URL created. It's nice and short. And let's plug this in and see if we get redirected. Awesome. So we've got the URL shortener built. It seems to be working correctly, and we've got it uploaded and running underneath our main domain name. So I think my job is done here. The boss should be happy. We've got the URL shortener built, and it's ready to go.
Okay, so Jason's home, and I'm always left with the fun stuff to do. I get an email from the boss asking how are we going to monitor and load test the URL shortener so that it'll work for the email campaign. And that's a legitimate request. You know, if we're not going to test it, we'll never know if it's working. And to be honest, I'm not exactly sure that this architecture is the right thing. We're using DynamoDB here. I want to make sure that if we hit a single entry point in the DynamoDB in that peak, it's going to withstand, that we provision enough capacity. There's some stuff behind this service. And so what we're going to do in this part of the demo, we're going to first generate some traffic. And so we'll create a little load generator, traffic generator, and hit our service to make sure that it's actually withstanding the load. And then we're going to add some monitoring to our system so we can see what's going on and make sure that we have visibility into the production system. Okay, let's just get going. So I synced from Jason's repository. You can see that if I run CDK Diff here, it'll tell me that I don't have any changes in my application, which is great. How do we generate load for a URL shortener? And so I've got this URL that I created earlier. It redirects to Amazon.com. And so basically an email campaign would have this type of load profile, right? Like all of our users are going to hit the same URL and going to be redirected to the same response. So it's basically a bunch of HTTP requests going into the same URL. So let's create a little script. I'll create a directory called pinger, and let's just start by just doing it with bash, right? While true, do, just hit this URL every second. That's a really simple script. It basically sends an HTTP GET request into a single URL. I can run this and make sure that it works. Let's see. Yep, looks good. And now what I'm going to do, I'm going to wrap it in a Docker container, and I'm going to use Amazon Fargate to orchestrate this and run it on the cloud, because I'm going to want to run it over the weekend and make sure that it runs. I'm not going to be able to run it from my own machine. And so let's create a simple Docker file here. We'll use Alpine as the base image. We're going to install curl. We're going to add our little ping script, and we're going to use it for our entry point. One thing that I think I did here that's wrong, Alpine doesn't have bash. Okay, and let's even try this. Docker build, pinger, Docker run, the URL again. Neat. Okay, so this little container generates a single transaction every second, which is the basic building block of a traffic generator. Now let's go to our CDK application and see how we can define our Fargate service to run this Docker image. So I'm back in my code, and what I wanted to show you now is this traffic generator thing is actually a pretty usable thing, pretty useful thing. We have another team in our company, in our fake company, that wants to run some generate some load against their service next month, and they asked if we can give them some of the stuff that we're doing. And so instead of writing this inside my application, what I'm going to do is I'm going to create a custom construct that will represent my load generator. I'm going to create it over here as a separate file, but as you know, if you're familiar with Python, like, it's very easy to take this file, wrap it in a library, publish it to PyPy, publish it to our internal repository, and so this is going to give you a sense of what it means to create custom constructs in the CDK, which is really an important capability we wanted to show you. We'll call it Traffico. All good reusable components have good fun names. Don't ask, please. Okay, so what is a construct? How do you define a construct? We wanted to make that as easy as possible. And so a construct in the CDK is basically a class that extends the construct base class. So what I'm going to do is I'm going to import the construct base class, and I'm going to define my traffic class as a subclass of construct. And so this is basically what you need to create a construct. And mostly, like any other code that you've seen already, the main business logic of the construct happens in its constructor. And so we're going to create a constructor here, an initializer in Python terminology. We'll call the base, super. And like Jason told you earlier, all constructs have a similar signature. They expect a scope and an ID. And so we're going to add those here. And basically this is it. This construct is completely viable construct. I can use it inside my CDK application, and we'll do that in a second. Now I wanted to create a Fargate service. So let's just explore the library through our IDE. I'll import from AWS CDK, import AWS ECS and AWS EC2. I'll need the EC2 library too. Okay, so we need a Fargate service. So I'm going to go ahead and define a Fargate service, self, and this is basically our pinger service. And you'll see that it basically requires if I look at the error here, sorry, besides the pedantic PEP 8, it tells me that I need a cluster and I need a task definition. So let's create one. Fargate services run within ECS clusters. So I'll need to do ECS.cluster, and then I'm going to do self and ping and whatever, we'll call it cluster. And what I want to do here, I want to run this cluster within the VPC that my company has. Like, we have a central VPC. All our applications run within the VPC, so it makes it easier to talk to each other. And in many cases, I actually want to generate traffic to an internal endpoint, not to an endpoint that goes on the internet. And so what I want to do here is I want to make the VPC a parameter to the Traffico construct. And so I'll just do this for now. And what I'm going to do here is I'm going to add a VPC keyword argument, and it's going to be of type ec2.ivpc. And the reason I'm using ivpc, which is an interface, is because we have a pattern in the CDK that allows you to either reference a construct that was created within your app, in this case it would be VPC, or a resource that was imported. And so this VPC specifically, I'm not actually defining that in my application. All I want to do is import it from some existing ID, and we'll see how to do that in a second. But for all intents and purposes for this Traffico construct, it's just an input. So I think it's pretty straightforward. So yeah, let's just put the cluster here. We have cluster, and then the second thing we needed was a task definition. So ECS and Fargate has this concept of a task definition, which basically allows you to define which containers need to run together, and then you can like specify how many times you want these tasks to run. So I'm just going to create a task definition here, Fargate task definition, and pinger task. And you'll see that a task definition accepts a bunch of parameters. I actually don't need to specify any parameter at the task definition level. I need to add a container to my task definition, and then that's going to be our actual, pinger. And the pinger accepts a required parameter called image, and that basically defines the Docker image that's running within that task, within that the container is based on. And so now we need to basically reference our little Docker image that we've created. You see that it's here in a separate directory. And now we're going to go back to using CDK assets, which Jason showed you earlier, how to use assets to define Lambda code. You can do the same thing with Docker images. And the experience is very similar. You go AWS ECS.container image.from asset. And then you basically specify a directory. And so in this case, I'm going to just say pinger, because it's a directory relative to the root of my application. The second thing I need to specify here, if you recall, was the environment variable. I need to tell it which URL to hit. And so obviously, if this is a general purpose traffic generator, the URL is going to be something that I expect as an input. And so I'm going to add URL here. If I want to be pedantic, I need to put star here, or star, something like that. Yeah, means that I need to specify all these as keyword arguments and not positional arguments. Okay, so I'm going to specify the task definition here as task def. And this is basically all I need to specify. You see that I don't have any other errors here for required arguments. But one thing that so this is going to work, but what's going to happen is going to generate a single transaction every second, and that's hardly the load that I'm expecting. I'm actually expecting much more. And so in order to actually scale this up, all I need to do is duplicate this container and run it as many times as I want based on the transactions per second that I want. We have this really nice one-to-one mapping between the concept of transactions per second and the number of containers running in our Fargate service. And I wanted to talk to you a little bit about this idea of abstraction, right? Like the traffic generator here, the mental model that a user has when they use a traffic generator is how much load to send over to a specific URL. And so they can specify the URL and they can specify transactions per second, let's say. Okay, that's like something that they understand, right? Like they don't care that under the hood, this abstraction is using Fargate, using containers, using some bash scripts. It doesn't matter, right? Like they just care that they want to send this amount of traffic to this URL, and I could change this implementation behind the scenes as long as it does what they expect it to do. That's great. And so CDK gives you the ability to define these abstractions, and I think what we're going to see is we're going to see people developing that skill of defining abstractions for infrastructure components, which are very similar to defining abstractions in your application code, but we weren't really used to doing that in the past. And so I think that's a new thing for many of the users that we see today that is really fun and interesting and creative. Okay, and so what we're going to do with this TPS is basically going to say desired count equals TPS. This is the translation of the mental models. Okay, so we've got our little construct. Now we need to use it, right? Like it's basically just a class right now, and I'm going to go to my application, and instead of actually adding that construct to our URL shortener stack, what I'm going to do is I want to create another stack for it, because it doesn't make sense. If you recall from our little graph here, we wanted the traffic generated to be in a separate stack, because we're just gonna destroy the stack at the end of the test, and we don't need to touch our application stack. So it makes sense that those things are deployed separately. Traffic stack. And that's also going to be a Walters co-stack, because all our stacks in our org are based on that base stack. And we're going to do the same thing that Jason did here, so I'm just going to spend my less time doing that. And now I'm going to import from Traffico, import Traffico. And so this would be, let's say I'm publishing this to PyPy or to our internal package managers. So this would be something that I would need to pip install, and then I get this little nice construct. And you see that when I'm instantiating Traffico, it looks and feels exactly like all the other constructs that Jason used earlier. It has scope, ID, and then it accepts these three parameters: VPC, URL, and TPS. Okay, so scope is always self, and then traffic, whatever, test traffic, and then VPC. So for VPC, what I'm going to do is I'm going to use the shared VPC that we have in our company, and I'm going to show you that basically if I go to self, we have Walters Co VPC, which is published by the Walters Co stack. And so similarly to the map Walters Co domain method that Jason used earlier to work with the shared domain resource, we have API that allows us to work with the shared VPC resource. And so like this idea of using a base CDK stack as a way to share resources between teams is something that we're starting to see with customers, and it's a simple object-oriented tool that we can now leverage. Okay, so we've got, sorry, that was the VPC, right? And then URL, I'm going to be lazy, sorry. I'm going to be lazy, I'm just going to use this URL for now. We could have, passed in the URL from the other stack and generated, but I want to keep things simple for now. And then TPS, let's say it seems like our DynamoDB table initially is provisioned, I think, with 5. Let's do 10, see how it behaves. So 10 TPS. Okay, last thing I need is to actually instantiate my stack, because now I've only declared it. I haven't really defined it. And obviously this one needs to be here because, again, we're very, very organized. So I'm going to go to my app. I'm going to import my traffic stack. And I'm going to add test traffic. Cool. So now we've defined the stack. Let's deploy it. So I'm going to do CDK Deploy test traffic. Let's see that it's starting. It should show me some nice information about any security changes that this requires, and that makes sense because there's a lot going on under the hood over there. Okay, so while this is deploying, and you see that it's building the Docker image for me, which is pretty neat, let's go back to our presentation and move on to the next part of the demo, which is the monitoring aspect. We're going to use CloudWatch dashboards and CloudWatch alarms for monitoring. And CDK today has a pretty neat API to define these dashboards. You can actually programmatically create these dashboards with widgets and grids. But it is still pretty involved. Like if I want a nice dashboard, I would need to understand all the metrics that are emitted by each resource and create alarms for them with reasonable values. And I really don't want to do that. What I'm going to show you is how we can use a third-party library that someone, incidentally it was me, published to PyPy that does that for us. Just demonstrating to you that what reusability is about, right? For infrastructure, it's a very powerful idea. Okay, so I'm going to do AWS CDK monitoring. And we've got this library here called CDK Watchful. And if I go into it, watching your CDK back since 2019, that's nice. It's an AWS Construct Library that makes it easy to monitor CDK apps. And you see that it's using JSII, similarly to what we use in the CDK, to publish this library to multiple languages. So it has support for Python and for TypeScript, which is great. And the way it works is you instantiate the watchful construct, and then you basically call watch DynamoTable, watch Lambda function, you pass in these resources, and you get this nice little dashboard with alarms set up for you, which is great. CDK Watchful is using this concept called aspects, and we'll talk about it in a second. Okay, so I'm just going to use this one. So pip install CDK Watchful is my first step. Terminal. So I'm going to bring in this library, and then let's see, is this still working? Yeah. Okay, so I'm going to go to my URL shortener stack here, and I'm going to import this library from CDK Watchful, import Watchful. And then I'm going to go to my main stack because, as I showed you earlier, I want my monitoring system to be part of my main stack, right? Like it's an integral part of my application. It doesn't make sense to deploy those separately. It could make sense to deploy those separately in certain circumstances. It's your choice. We're just going to add it to the main stack. So I'm going to do watchful self monitoring. I can even specify an alarm email. So I'm going to specify Jason's email here because why not? And let's look at this API. So I've got watch Lambda function, watch DynamoTable. It's pretty nice. Even add specific alarms and sections to my dashboard. But there's another interesting API here called watch scope. And what this API is doing, let's look at our docs for a second. Watch scope, watching scopes. Watchful can also watch complete CDK construct scopes. It'll automatically discover all watchable resources within that scope recursively, add them to your dashboard, and configure alarms from them, which is pretty neat because that will save me a lot of time. And I really do want to watch everything in this stack. So I'm going to just do this, right? I'm just going to create a watchful instance and tell it to watch this stack. And it'll automatically find all the relevant resources. We'll see that in a second. Okay, are you done? Yep. Okay, so supposedly we're generating some traffic. We can't really know. I can check out that we have some, maybe I can, just for the sanity, I'm gonna do a little test here and see that I have my little ECS Fargate cluster defined. Yep, that looks like it's doing something. I've got 10 running tasks, which is what I asked for. And so the next thing I'm going to do is I'm going to do CDK Diff to see what's going to happen after I've added this monitoring system. And it looks like it's doing what it needs to do, right? It created a subscription for JSON, it created a dashboard, it created alarms for me. I'm just going to deploy this thing. Star means deploy. Oh, sorry, not diff. Deploy. Star means deploy all the stacks, and obviously my traffic generator hasn't changed, so it's supposedly it shouldn't do anything. Okay, so while this is deploying, let's go back and recap, and then we'll come back as soon as it's over. So what have we seen here? First of all, we've seen Fargate is awesome. Like, I can't stress how much heavy lifting is being done for you to take this little Docker image and just like spin up 10 instances of it running as easily as this. It's all working together within the CDK workflow, so any changes to the Docker image would automatically reflect and update. It is awesome. We talked a lot about reusable constructs. This is the main thing that we want you guys to take from this talk. This idea of being able to create arbitrary abstractions, share them, reuse them, publish them to package managers. We talked a little about APIs, encapsulation, mental models, and then when we saw the monitoring, we saw how to use a third-party construct library. We found it on PyPy. Think about this idea of like this little cloud in a library or a service in a library. We also saw that it's possible to use JSI, which is a technology that we use to publish a CDK to multiple programming languages for any other library. Okay, so let's see if our little, I even get a little link here for the dashboard. That's pretty neat. Boom. Cool. So we've got our little mapping table. This is Dynamo table monitoring. We can even see that it started getting some traffic here. We see the backend function getting some invocations. We see the API gateway getting overall calls, latency. Perfect. This is what we need. Jason's going to wrap up.
Thank you all for coming to this session today. I hope you enjoyed the demo. Alad and I really had a lot of fun building this with the CDK, and I hope it inspired you to get your hands on the CDK and explore it yourself. For next steps, in terms of learning about the CDK and exploring it on your own, I hope that you will all go check out cdkworkshop.com. This is a little online interactive workshop that we've built, and it's available in TypeScript and in Python. You can go and get your hands on the CDK and learn about the main concepts and have fun building a small little app. And of course, we're on GitHub. We're very active on GitHub and Gitter. We'd love for you to connect with the development team. Let us know how your experience is going with the CDK. If there are features missing or any issues you've hit, we'd love to hear from you.
Yeah, thanks so much for coming. One of the things we talked about a lot in this session and showed you was how easy it is to create your own constructs. And so we're really curious about what you guys are building with the CDK, and we encourage you to like share it with your team, your company, publish it to one of the open source package managers. We think this can have incredible impact on how people build cloud applications, and we can't wait to see what you guys are going to build with it. So yeah, thanks so much for coming.